In this video, I will show you how to conduct a t-test in R. First, we'll load the Haven, Tidyverse, and Psych packages. And then we'll import the Harry Potter dataset and calculate the mean personality scores for each participant. And next, we'll recode the coin flip variable so that we can use it as our independent variable. And finally, we get to conduct the t-test. Now, because it's easier to type the variable name within the Tidyverse, I'm going to pipe dataset into the with command. The with command will then feed dataset into t.test. And t.test is what will conduct the t-test for us. And the advantage of doing it this way is that we'll be able to just type the variable names that we want instead of having to do a little bit more typing by first referring to dataset, $ variable name. We now can just type the name of the variable. So for example, if you want our DV to be extroversion, we can just type extroversion and we'll put a tilde, and then we can list what we would like our independent variable to be next, and that's going to be coin flip factor. And all we have to do now is press play. And so you can see it conducted a Welch two-sample t-test. We can see our t-value, our degrees of freedom, and the p-value. And it also tells us the means for two groups. So for the mean of the group heads was 2.99, and the mean of the group tails was 3.14. And that's not a significant difference between those two groups. Now, it's also possible to specify a few parameters for this t-test. For example, maybe you don't want to do a Welch two-sample t-test. Maybe you want to do the more common student's t-test that is the normal default. In that case, we can see our t-value, our degrees of freedom, our p-value slightly different, and we can see our means. Our means are exactly the same, but once again, we would not reject the null hypothesis here. We can add some additional parameters as well. Like for example, maybe our hypothesis wasn't that there'd be any difference between heads and tails, but maybe we predicted that heads would be people in the heads condition would be lower in extroversion than participants in the tails condition. In that case, we can write, and the reason we can write alternative equals less because we're predicting that heads is less than tails. And again, we can see that the same degrees of freedom, a different p-value, but the same means. We can also test whether we thought heads would be greater than tails. Maybe that was our a priori prediction. In that case, we get different p-value, different means, and that's really all there is to conducting a t-test with R.